Good morning. Today I'm going to cover Chapter 6, and that's working with DOS and Windows systems. Here we go. These are the objectives that we're going to cover. Now, it's very important to understand how DOS and Windows file systems are constructed and work, because if you're going to be doing forensics on these operating systems and file systems, it helps to know where the data would be. Okay. We're also going to talk about the registry. Okay, first of all, file system. A file system gives an operating system a roadmap to the data on a disk. The type of file systems an operating system uses determines how data is stored on a disk. A file system is usually related to the operating system. When you need to access a suspect's computer to acquire and inspect data, you should be familiar with that computer's platform. The boot sequence. To ensure that you don't contaminate or alter a suspect's Windows or DOS PC, you must know how to access and modify a PC's CMOS, complementary metal oxide semiconductor, and BIOS, basic input-output system settings. A computer stores system configuration and state and date and time information in the CMOS when the power to the system is off. The BIOS contains the programs that perform input and output at the hardware level. The bootstrap process is contained in read-only memory, ROM, and tells the computer how to proceed when booting. It displays the key or keys you press to open the CMOS setup screen. CMOS should be modified if you want to boot from a forensics floppy disk or CD. Disk drives are made up of one or more platters coated with magnetic material. Some of the drive components include the geometry, the heads, the tracks, cylinders, and sectors. Each concentric circle is a track. Each wedge-shaped area is called a sector. Each combination of tracks forms a cylinder, which is stacked on another platter. Okay. Some of the properties handled at the drive's hardware or firmware level include zone bit recording, or ZBR, track density, area density, head and cylinder skew. In Microsoft's file structures, sectors are grouped to form clusters, which are storage allocation units of one or more sectors. Clusters are typically 512, 1024, 2048, or 4096 or more bytes each. Combining sectors minimizes the overhead of writing and reading files to the disk. Clusters are numbered sequentially starting at 2 because the first sector of all disks contain the system area, the boot record, and the file structure database. The operating system assigns these cluster numbers, which are referred as logical addresses. Sector numbers are referred to as physical addresses. Clusters and their addresses are specific to a logical disk drive, which is a disk partition. A partition is a logical drive. The FAT16 file system does not recognize disks larger than 2 megabytes, so large disks have to be partitioned into smaller sections. Hidden partitions or voids as large unused gaps between partitions on a disk drive. A partition gap is the unused space between partitions. A disk editor utility could be used to alter information in a disk partition table to hide a partition. One way to examine a partition's at the physical level is to use a disk editor such as Norton Disk Edit, WinHex, or Hex Workshop. The tasks involve analyzing the key hexadecimal codes the operating system uses to identify and maintain the file system. With tools such as Hex Workshop, you can identify file headers to identify file types with or without an extension. The master boot record on Windows and DOS computer systems, the boot disk contains a file called the master boot record, or MBR, which stores information about partitions on a disk and their location, size, and other important items. Several software products can modify the master boot record, such as Partition Magic's Boot Magic. The file allocation table disk. File allocation table, or what I'll call FAT, is the file structure database that Microsoft originally designed for floppy disks. It was used on file systems before Windows NT in 2000. A FAT database is typically written to a disk's outermost track and contains file names, directory names, date and time stamps, the starting cluster number, and the file attributes. Note that there are several versions of FAT that evolved over time: FAT 12, FAT 16, FAT 32, and VFAT. Cluster sizes vary according to the hard disk size and file system. Microsoft's operating systems allocate space for files by clusters. This practice results in drive slack, which is composed of the unused space in a cluster between the end of an active file and the end of the cluster. Drive slack includes RAM slack and file slack. Oh yeah, an unintentional side effect of the FAT16 file system having large clusters is that it reduced fragmentation as cluster size increased. When you run out of room for an allocated cluster, the operating system allocates another cluster for your file, which creates more slack space on the disk. As files grow and require more disk space, unassigned clusters are chained together. The chain can be broken or fragmented. When an operating system stores data in a FAT file system, it assigns a starting cluster position to the file. Data for the file is written to the first sector of the first assigned cluster. When this first assigned cluster is filled and runs out of room, FAT assigns the next available cluster to a file. If the next available cluster isn't contiguous to the current cluster, it becomes fragmented. In Microsoft operating systems, when the file is deleted, the directory entry is marked as a deleted file with the hex E5 character replacing the first letter of the file name, and the FAT chain for that file is set to 0. Data in the file remains on the disk drive. The area of the disk where the deleted file resides becomes unallocated disk space. This space is now available to receive new data from newly created files or other files needing more space. However, until it's used, the data can be retrieved. In the NTFS file system, the new technology file system, it was introduced with Windows NT as the primary file system for Windows Vista and later Windows 7 and 8. Improvements over the FAT file system include the NTFS provides more information about a file. With NTFS, you can also have more control over files and folders. NTFS was Microsoft's move forward towards a journaling file system. In NTFS, everything is written to the disk is considered a file. On an NTFS disk, the first data set is the partition boot sector. Immediately after the partition boot sector is the master file table. NTFS results in much less slack space. Clusters are smaller for smaller disk drives. NTFS also uses Unicode and International Data Format. The master file table contains information about all files on the disk, including the system files that the operating system uses. In the MFT, the first 15 records are reserved for system files. Records in the master file table are referred to as metadata. In the NTFS metafile table, all files and folders are stored in separate records of 1024 bytes each. Each record contains file and folder information. This information is divided into record fields containing metadata. A record field is referred to as an attribute ID. File and folder information is typically stored in one of two ways in a master file table record: resident or non-resident. Files larger than 512 bytes are stored outside of the master file table. An MFT record provides cluster addresses where the file is stored on the drive's partition. These addresses are referred to as data runs. Each MFT record starts with a header identifying it as a resident or non-resident attribute. When a disk is created as an NTFS file structure, the operating system assigns logical clusters to the entire disk partition. These assigned clusters are called logical cluster numbers, or LCNs. LCNs become the address that allow the master file table to link to non-resident files on the disk partition. NTFS data streams. Data streams are ways data can be appended to existing files. Data streams can be obscure, valuable evidentiary data, intentionally or by coincidence. In NTFS, data stream becomes an additional file attribute and allows the file to be associated with different applications. You can only tell whether a file has a data stream attached to it by examining the file's master file table entry. NTFS compressed files. NTFS does provide compression similar to FAT, drive space 3. Under NTFS, files, folders, or the entire volume can be compressed. The most computer forensics tools can uncompress and analyze compressed Windows data. The encrypting file system in Windows. The Windows Encrypting File System, or EFS, was introduced with Windows 2000 and implements a public key and private key method of encrypting files, folders, or disk volumes. When Encrypting File System is used in Windows Vista Business Edition or higher, or Windows 7, Windows 8 Business Edition or higher, XP Professional or 2000, a recovery certificate is generated and sent to the local Windows administrator account. Users can apply the encrypting file system to files stored on their local workstations or a remote server. The EFS recovery agent implements the recovery certificate, which is in the Windows administrator account. Windows administrators can recover a key in two ways, through Windows or from an MS-DOS command prompt. Windows administrators can recover with the following MS-DOS commands: the cipher command, the copy, and the EFS recover, which is used to decrypt EFS file systems. Deleting NTFS files. When a file is deleted in Windows XP 2000 or NT on an NTFS file system, the operating system renames it and moves it to the recycle bin. Another method is to use the delete key, or delete command, MS-DOS command. This method eliminates the file from the master file table listing in the same way FAT does. Whole disk encryption. Recent years, there's been more concern about the loss of personal identity information and trade secrets caused by computer theft. Of particular concern is the theft of laptop computers and other handheld devices. To help prevent loss of information, software vendors now provide whole disk encryption. Current whole disk encryption tools offer the following features: pre-boot authentication, full or partial full or partial disk encryption with secure hibernation, advanced encryption algorithms, key management function, a trusted platform module, microchip to perform encryption keys and authenticate logins. Whole disk encryption tools encrypt each sector of a drive separately. Many of these tools encrypt the drive's boot sector to prevent any efforts to bypass the secure drive's partition. To examine an encrypted drive, you must first decrypt it, which means you must run a vendor-specific program to decrypt the drive. Microsoft BitLocker. BitLocker is available only with the Enterprise and Ultimate editions. Current hardware and software requirements for BitLocker include a computer capable of running Vista, Windows 7, or Windows 8, the TPM microchip version 1.2 or newer, a computer BIOS compliant with the Trusted Computing Group, 2 NTFS partitions, and the BIOS configured so that the hard drive boots first before checking other bootable peripherals. How to use BitLocker, I will download a document and attach it in Blackboard to where you started running this video, and it will describe how BitLocker works and how to use it. Third-party disk encryption tools. Some of the third-party disk encryption tools include PGP whole disk encryption, Voltage Secure Disk, Ultimaco Safeguard Easy, Jetico Best Crypt Volume Encryption, Soft Winter Sentry 2020 for Windows XP. Some open source encryption tools include TrueCrypt, CrossCrypt, and FreeOTFE. Understanding the Windows Registry. The Windows Registry is a database that stores hardware and software configuration information, network connections, user preferences, and setup information. For investigative purposes, the registry can contain valuable evidence. To view the registry, you can use the regedit command program for Windows 9 systems and reged32 for 2000 and XP. You should become familiar with the registry terminology: registry editor, H key, subkey, branch value, default value, and hives. This table shows how registry files are organized in all Windows systems and what their purpose is. One of the easiest ways to examine the registry is to load an image of a Windows machine into Access Data as FTK and then click File, Registry Viewer. ProDiscover Basic can extract system.dat and user.dat from an image file. And these are just some figures that show Access Data Registry Viewer being used. Microsoft Startup Task. In this section, you'll learn what files are accessed when Windows starts. This information helps to determine when a suspect's computer was last accessed, which is particularly important with computers that might have been used after the incident was reported. Startup in Windows NT and later. All NTFS computers perform the following steps when the computer is turned on: the power on self-test, initial startup, the boot the bootloader, hardware detection and configuration, loading of the kernel, and user logon. In Windows XP, the startup files are the NT loader, the boot.ini, bootsec.dos, and these other file names that you'll see here. In a Windows XP system, these are the files and what their description is. When you start a Windows XP NTFS workstation, several files are accessed immediately. The last access date and timestamp for the files change to the current date and time. This change does destroy any potential evidence that shows when a Windows XP workstation was last used. In Windows 9 or 9X or ME, when they're talking 9X, they're talking anything from Windows 95 through 98 or Windows Millennium. The system files contain valuable information that can be altered easily during startup. Windows 9X and Windows Millennium have similar boot processes. With Windows Millennium, you can't boot to a true MS-DOS mode. Windows 9 operating systems have two modes: DOS protected mode interface and protected mode GUI. System files. The system files Windows 9X uses have their origin in MS-DOS 6.22. The io.sys file communicates between the computer's BIOS, the hardware, and the operating system kernel. If F8 is pressed during startup, io.sys loads the Windows startup menu. MS-DOS.sys is a hidden text file containing startup options for Windows 9. The command.com provides a command prompt when booting MS-DOS mode DPMI. MS-DOS startup tasks. Following two files are used to configure MS-DOS at startup: config.sys and autoexec.bat. io.sys is the first file loaded after the ROM bootstrap loader finds the disk drive. MS-DOS.sys is the second program to load into RAM immediately after io.sys. It looks for the config.sys file to configure device drivers and other settings. MS-DOS.sys then loads command.com, and the loading of command.com as it nears completion, MS-DOS.sys looks for and then loads and executes the commands in autoexec.bat. Other disk operating systems that you might encounter: control program for microprocessors, or CPM, digital research disk operating system, we used to call it Dr. DOS, and the PC DOS operating system. MS-DOS equivalent that IBM supplied with their PCs. Now, will you still find these? Occasionally, yes. It's becoming less and less frequent, but you still should be aware of them. Okay. Virtual machines. A virtual machine allows you to create a representation of another computer on an existing physical computer. The virtual machine is just a few files on your hard drive. You have to allocate space for it. Okay. Let's see. A virtual machine recognizes components of the physical machine it's running on. The virtual operating system is limited by the physical machine's operating system. In computer forensics, virtual machines make it possible to restore a suspect drive on your virtual machine and run non-standard software the suspect might have loaded. From a network forensic standpoint, you need to be aware of some potential issues such as a virtual machine used to attack another system or network. Steps to create a virtual machine. There are several different applications for creating virtual machines. VMware and Microsoft Virtual PC are two such tools. Hyper-V, Dropbox, VirtualBox, Parallels. There are others. Okay, but this section of the chapter mentions VMware and Virtual PC. For Virtual PC, you can download and install the Virtual PC program first, and then install it. Here they are. Now he's creating a virtual machine. And basically, you configure the virtual hardware that you are going to create, the size of the hard drive, how much RAM you're going to give the virtual machine, things like that. Also, for the operating system that's going to run on the virtual machine, you need an ISO image of the operating system or the disk media equivalent, because no operating systems are provided with Virtual PC. Virtual PC creates two files for each virtual machine. A VHD file, which is the actual virtual hard drive, and a VMC file, which keeps track of configurations you make on to that disk. To see what type of physical machine your virtual machine thinks it's running, you should open Virtual PC Console and click Settings button. There we are. Well, that kind of snuck up on me. We're at the end of the chapter.